All right, so my name is John Sherwin. I'm with the Florida Solar Energy Center, and I'm here today to give you just a quick overview of some of the current field studies that we have regarding some of the PV stuff that we're doing. So just as a quick background, my name is John Sherwin, and I actually started at the Florida Solar Energy Center as a UCF student in 1987, and after I graduated, I stayed there and kept on going because I found the work to be very fulfilling and very worthwhile, and we've done a lot of great things over the years since I've been there. So the first project I'd like to talk about is one it's called quantifying and valuing the fundamental characteristics of and benefits of floating PV systems. So for those of you who don't know anything about that, floating PV it actually started as a very niche market, but in the last 5 years, it's grown 100-fold. One of the main reasons behind that is, land is becoming more and more scarce, and it's becoming more and more expensive. So people are looking for places to put PV. And while floating PV has been around for a little while, and it's big over in the international market, a lot of places in Asia and even in the Netherlands, and in some of those areas, Europe, it hasn't really caught on that much in the United States. And particularly in the United States, the opportunities to put floating PV is pretty extensive. NREL did a study and they identified 25,000 man-made bodies of water, where if you only covered about a fraction of it, a quarter of it, you could supply 10% of our nation's energy needs. So this project, and to put that in perspective quickly, in and around the city of Orlando and Central Florida, there are nearly 6,000 bodies of man-made bodies of water that could be used for floating PV. So what this study is trying to do is that there's a lot of I like to call them, some people call them myths about how PV works and what are the benefits. One of those might be that because the PV sits on water, there might be a little bit of a cooling effect to that, and can increase the output performance. And then that is true to a certain extent, but some of the documentation is varied and kind of difficult to get a hold of. So the other thing that we're interested in with floating PV is to look at its environmental characteristics. So this project also looks at some of the water quality issues surrounding a floating PV system and biodiversity. Particularly, we're interested in some of the avian species and in some of the bugs that live in the water. So one of the innovations here too is that what we're going to do is for each one of the sites that we're monitoring, we have a corresponding land-based site. So the interesting thing here is that while you have a floating PV system, there's not a lot of models out there that can help identify and characterize the performance of those systems. So the best thing that we can do is, and what they're doing now, is they're actually using land-based PV performance models. So what we're going to do is compare the land-based ones that we know model correctly with the floating ones, and then sort of tweak those models and work in that direction. And so we're working with NREL on that to do that type of work. So we have, let me go to the next slide here. So here's just some quick field photos that we've taken. We have four sites that we're monitoring, floating sites. Two are in Florida and two are in California. So the two in Florida, one is over at OUC there, off of Gardenia there, off of 33rd Street there near I-4. The other one is in Altamont Springs, which is their water reclamation facility. The other two floating sites there's one in Sonoma, California. That's what you're seeing there in the top left, and then the bottom left is a giant one in the city of Windsor, and that's also a water reclamation facility. Some of the other pictures that you're seeing there are is just the ones the field personnel. We have these devices that we take and we troll around the water, and we take quarterly measurements of the water quality. We're also taking a lot of temperature measurements because one of the things that they're interested in is how floating PV affects the water temperatures and which indirectly or directly affects water quality. And then there's a little picture there. You may not know it, but we actually have beavers in Florida, and I did not know that. But that's one a beaver stuck his head up out of the PV array over in Altamont. So that's that study. The other study that I'm involved in is that people may not know this, but there's something known as a regional test center put on by the Department of Energy. And there are 5 of them in the United States, and FSEC hosts one of those. So what a regional test center is, it's essentially sort of an outdoor laboratory or testing ground for PV systems. And one of the main the main idea behind it is that we are establishing protocols and using the instrumentation techniques and data analysis techniques that are all standardized and can be referenced back to one place. In particular, that happens to be Sandia National Labs. So the focus is really on these projects is on very high quality data for our experimental PV systems. It initially started looking at sort of emerging technologies, and it still does do that, but we're also working with partners for different types of looking at different types of PV systems that might have been manufactured in different ways, and they're sort of testing the durability and reliability of those systems. And so they can deploy those around the United States and essentially during one test period can see it over 5 different climate groups. So in particular, there on the top right-hand side is shows where they are. So Florida here, we're the hot, humid environment. We have one in Michigan, which represents the cold. We have one in Colorado, which is the sort of a high altitude cold. And then you've got the other 2, which are more of the arid desert mix. So we can test PV systems under those particular conditions. And one of the other things too is that it's also a very good way to kind of test instruments and develop best monitoring practices within all the different environments. So here's some quick photos of these installations. The one in the top left-hand corner, that is our auxiliary site at the Florida Solar Energy Center. So there's 200 kW of PV panels under test. The ones there you see kind of running perpendicular to the other ones. Those are old panels that aren't really being used anymore. That was an old helioscope project. But the first couple of ones in the foreground, those are baseline systems. So those are standard technology systems that have been monitored since that site was installed. And so all the other systems can be compared relative to those. Also, we have a fully functional 10-meter standardized MET station. And so what you're seeing there on the right-hand side is our solar tracker, which helps us look at the different aspects of the solar irradiance, particularly GHI, which is global horizontal irradiance. We look at direct, normal, and diffuse, so we can quantify the irradiance that the systems are getting. And then down on the bottom here are some other studies that are within there. We don't just test panels. The one there on the bottom left was some coupon samples that we did where we're looking at some clear coatings that might be used on PV systems, and they had different chemical aspects for like water shedding, and also we looked at the transmissibility of them and some other factors. There in the middle, we're doing some work with looking at different types of PV panels, like bifacial panels, on different types of rooftops and how the albedo affects that. So in there, you're seeing right there, you're seeing a sort of a flat roof kind of commercial one, and then behind that we have a standing seam metal, and then we also have a white flat barrel tile. But it's not really barrel; it's flat. And then down there on the lower right-hand side, we're starting to work in looking at systems with building integrated PV. So on that particular slide there, you're looking at some solar shingles, and then we have some control modules there on the end for comparison. The last project I want to talk about is one where we're analyzing some of the I guess you would call it the fallout from some emergency shelters that were installed, some standalone emergency shelters that were installed for back in 2010. So there was let's see, I have the stats on that. There was, oh, there it is. No, there's right there. There was 118 shelters installed in 2010, and they worked great for a couple of years, but over 10 years, they've kind of fallen into disarray. So we now have a project that is going out and looking at all those individual sites and assessing how they're working, what they're doing with them now, and anything that can be done as far as developing ways to make sure that they work. Because one of the things we found is that over the years, these systems sort of, fell into neglect. And I'll show you some pictures here in a second about some of the stuff that went down. But right now, the project it was in two phases. One was to go out to all the sites and inspect them and write a report on that, and then there was some follow-on work to look at the ones that were not in that bad a shape and actually do some full retrofits and repairs, and that includes replacing batteries. So 55 of the shelters are getting a replacement of 16 batteries, along with some inverters and some other stuff. So let's see here. Going on to, I don't know what I'm doing on time. So here's some kind of interesting photos of how these systems kind of fell out over the last almost 12 years. You can see some of them there where there on the top right-hand side, someone actually removed panels. We don't know why or where they went to. You can see one in the middle that's kind of interesting. You got a tree growing out of it. And then you've got, and there's one of our colleagues. He's got, that's like Tom Brady there, the goat. They had a goat and some storage. It turned into a storage area. This was on school grounds. In some other areas there where they've let full-on trees grow. And so the system kind of fell into disarray. A lot of that has to do with some of the policies that were enacted. These systems were sort of given to the schools and the school districts. So depending on the funding of that individual district or how the school maintained them really depended on whether the system still worked or not. So so that's sort of the quick of it. Are there any questions? Oh, let's look at opportunities. I'm sorry, I have one more slide here. So in the near term on our floating PV, we're going to work on refining some of the models from the field data. We also want to start to look at more biodiversity. Right now, they were centered, we're working with UC Davis on this, and we were centered on just a few species. They want to, based on what they're seeing at the individual sites, they want to start to look at those particular species and then actually go out and to find some control ponds and see how these species act in with floating PV versus not. Another thing of interest is to look at the micro impacts of the floating platform materials themselves. One of the spin-off projects has been to take some of these floating devices and put them in water and then start measuring to see if there's been any degradation of them over time. With the Florida RTC, one of the things we're doing with that site is right now it's a remote site. We're going to move that over to our main campus so that we can start to connect that right to our grid. Out where it is right now, there really isn't any load per se. So what we want to do is bring it over to FSEC and actually use that energy for our own campus and to support our own energy needs. They also want to expand to module level power electronics and look at more bifacial technologies. And then we're also actively pursuing partnerships with Florida-based PV manufacturers. Trina just built a big plant, and we're starting some relationship with them to do some testing with those guys. On the SunSmart Shelter program, they want to continue monitoring the retrofits rather than just look at them once. They want to start to develop more of a uniform inspection protocol and more regular inspections to make sure they don't fall apart again. Again, establish protocols for long-term maintenance, and also look into some of the some more cost-effective strategies to see if we can remotely monitor them. Each of the sites did have their own remote monitoring capabilities, but when the project money fell through, a lot of that the funding couldn't support the ongoing monitoring of them, and so we're trying to find out ways to help the schools be able to monitor those and use them not only in the classrooms but to report to emergency agencies about their availability. So in the long term for our floating PV, we want to try to optimize some of the models that we're using for specific platform types, and then look at some of the durability and the water interactions that the different platforms might have. And in particular, too, how we can maybe modify the designs to help enhance any performance effects of those systems, based on the data we're taking. On the RTC front, Florida notwithstanding, they are DOE is also looking at expanding this to an international level, and they already are working on that, but they want to build that even more. So they're calling that the PV Camper, which is the Photovoltaic Collaborative to Advance Multi-Climate Energy Research. So that's a mouthful, but what that is it's essentially taking lessons learned here in the United States and even at our own site here at FSEC and applying those out across the planet, or the globe, so to speak, to an international community, so that we can develop standards that collectively help all the PV research and help create some really high quality data that's uniform and been well vetted. And then lastly, on the SunSmart program, again, we're trying to work more and coordinate with agencies to help manage some of these emergency shelters. What ended up happening, and sort of the dirty little secret behind some of these systems were, these PV systems, might have been installed at a school where, the administration was very happy to have them there and they were excited about them, but then sort of as the glimmer wore off, they started to see a little more as a liability. They couldn't afford to keep them up. Maybe they didn't want to be an emergency shelter. And so there are some issues there about how you coordinate that and sort of the public policy and even school policies about how all of this gets implemented. And then lastly, create some uniform monitoring protocols for each shelter. Can we get all these things coordinated and we can look at them and then take those lessons learned and start to expand them, to other schools and other types of shelters. So that's.
Thank you, John.